Now let's look at the page 544, problem 51. And in this problem, we know the sine of this half angle and also know the position of this half angle. Then we need to find the other 6 trigonometric functions at the angle alpha. Now let me copy this problem on the whiteboard. So it's page 544, problem 51. Sine of half alpha is equal to 4/5, and the half alpha is in the quadrant 2. And let's first try to find the cosine alpha. We know we have the double angle identity for cosine. Cosine alpha is equal to 1 minus 2 times sine square of half alpha. So now you plug in this 4/5 for this sine of half alpha. Then you get 1 minus 2 times the square of 4/5. And then you get 1 minus 2 times 16/25. And this is equal to 1 minus 32/25. And then from here, you get 25 minus 32/25. And this is equal to negative 7/25. And after we find the cosine alpha, we can use the fundamental identity to find the sine alpha. And before we find the sine alpha, we need to determine the position of the alpha. Since we know half alpha is in the quadrant 2, so that is the 90 degrees less than the half alpha, and this is less than the 180 degrees. So we multiply each part by 2, then we get 180 degrees less than alpha less than the 360 degrees. So this implies alpha is in the either quadrant 3 or quadrant 4. So alpha belongs to quadrant 3 or the quadrant 4. And in these two quadrants, sine is negative. So we can use the fundamental identity to get sine alpha is equal to negative root of 1 minus cosine square alpha. Then you plug in the values, okay, for the cosine alpha into this expression. Get negative square root of 1 minus the square of the negative 7/25. And then simplify, you can get 1 minus 49 over the 625, and this is equal to negative square root of the 625 minus 49 over 625. Then continue to simplify. This is equal to negative square root of 576 over the square root of the 625. And the square root of the 576 is equal to 24. And the square root of the 625 is equal to 25. So in this way, we find the sine alpha. And then we can continue to find the tangent alpha, which is equal to sine alpha over cosine alpha. So sine alpha is equal to negative 24 over 25 and divided by cosine alpha, negative 7 over 25. Then you multiply both the numerator and denominator by 25 and also cancel this to negative sign. Then you get 24 over 7. Then you can find the cotangent alpha. Cotangent alpha, which is equal to the reciprocal of tangent alpha. So you just need to invert this fraction. Then you have the 7 over 24. Now let's move to the next page to find the secant and the cosecant. Secant alpha, which is equal to the reciprocal of the cosine alpha. So cosine alpha is equal to negative 7 over 25. So now you invert this fraction, then you get negative 25 over 7. And for the cosecant, it is equal to 1 over sine alpha. So sine alpha is equal to negative 24 over 25. Then you got negative 25 over 24. Okay, then done. Now let's look at the page 542. Example 6, try this part. We need to prove this equation is an identity. Let me copy this equation on the whiteboard. So it's page 542, example 6, try this part. And we need to verify this identity. Cosine of 3x equal to cosine cubed x minus 3 times cosine x times sine square x. Although the right side is more complicated, and this time we need to start with the left side because the left side involves the multiple of angle. So we can use the cosine of a sum to rewrite this cosine of the 3x. We may write this cosine of the 3x as the cosine of 2x plus x. Now we can apply cosine of a sum identity. So it's equal to cosine of 2x times cosine x minus sine of 2x times sine x. Now, for this cosine of 2x, we can use the double angle identity for cosine, which is equal to cosine square x minus sine square x, and then times cosine x. Then for this one, we can use the double angle identity for sine. So we got 2 times sine x times cosine x and times another sine x. Then we simplify. So cosine square x times cosine x, you have the cosine cube x. And then here you have the sine square x times cosine. So let me write this cosine first, and then sine square x. Then for this one, you also have the cosine x times sine square x. So you have the 2 times cosine x times sine square x. And then you combine these two negative terms, you have the cosine cubed minus 3 times cosine x times sine square x. Then this is equal to the right side. So and now we verify this identity.